welcome, and thank you for joining us here in the Void for another monthly grab of galactic gazing. I'm Ben Wright, Immersive Experiences Coordinator for the Danville Science Center, and your host for this afternoon's tour of the night sky for the month of June 2021. Today's virtual online interstellar discussion is presented by our friends at Danakid Associates and is interactive as always. You are invited to participate in the chat throughout our survey, typing your comments and queries such that I may go back and attempt to respond to some of them at the end of our tour. If you miss any of today's live broadcast, you can go back and view recordings on the Danville Science Center's Facebook or YouTube pages. Let's discover our world. We begin as we always do here outside of the Digital Dome Theater in the backyard of the Danville Science Center. We are facing, of course, the southern sky. If we take a few steps back and look to our right, we are facing west. To our left is east, meaning, of course, north is directly behind us. It is, as we can see in the corner, just a few minutes past noon on Tuesday, June the 8th. And if we look upward towards the sky, we see the star, of today's episode of Void, our central star, the sun. But if you look really close to the right of the sun, you'll spot another little glimmer of light that is our moon. Last month, we talked about lunar apogee and perigee and micro and supermoons. See? Around that time, our moon was at apogee, the farthest point from Earth in its monthly orbit. Sure enough, last night, the moon again reached apogee, placing it some 406,000 kilometers from Earth. The exact period of the moon's cycle between apogee to perigee and back to apogee again is 27.56 days, slightly longer than the moon's orbital period of 27.32 days. This span is known as an anomalistic month and is due to the moon's orbit being elliptical rather than a true circle, and due apogee moving in the same direction as the moon as it is orbiting the Earth. The moon takes slightly longer to return to apogee than to return to the same star. This also explains some of the discrepancy between lunar and solar calendars. Today, the moon reaches perihelion, the closest point to the sun during its orbit around the Earth. This happens when the moon's orbit carries it between the sun and the Earth at around the same time that it passes new moon. We can just barely spot our moon in tonight's sky. As we zoom in, we can tell that at 28 days old, it is currently in the waning crescent phase. It's its last stop before becoming a new moon and beginning the cycle all over again. The placement of the moon between the sun and Earth also positions it for another celestial phenomenon, an annular solar eclipse. Again, last month on the 26th, we experienced a lunar eclipse, when the moon passes opposite the Earth from the sun, resulting in the Earth casting a shadow on the moon. This Thursday, the moon will pass between the Earth and the sun, producing a solar eclipse, but not a total solar eclipse. Solar and lunar eclipses always come in pairs, with one following the other about 2 weeks apart. If the Earth and the moon travel through space in the same orbital plane, then we experience 2 eclipses every month, but they don't. The moon's orbital plane is about 5 degrees off from the ecliptic, the name given to Earth's path around the sun. This difference results in the moon intersecting with the ecliptic only twice a month at points called nodes. If the moon is moving from south to north, it's called an ascending node. If from north to south, it's called a descending node. If a full or new moon occurs during one of these nodes, an eclipse occurs. Thursday will present an ascending node annular solar eclipse. Because the moon will be 251,000 miles from the Earth, it will appear 5.7% smaller than the sun. As a result, the moon will only block out the center of the sun, leaving its outer edges as a ring of light, or annulus, still visible. Thursday's eclipse will be most viewed from parts of northwest Greenland and Russia, but will be somewhat visible as far south as the Carolinas. Here in Danville, the sun will be eclipsed to a maximum of 22% around 6 a.m., right as the sun is coming up to greet the day. If you sleep in a bit, you may still find something very interesting joining Thursday morning's sun shooting stars. The Aratid meteor shower peaks Thursday morning and is a daytime meteor shower. It is visible whenever its radiant point in the constellation Aries the Ram is above the horizon, which can be as late as 10 a.m. Though the most spectacular displays are still right before dawn in Danville, we should be able to spot as many as 16 shooting stars an hour before the shower moves beyond visible sight lines. The apparent height of stars in the sky changes throughout the year. Being a star, our sun is no exception. It's about to reach the longest and highest point in the sky. The sun will make its annual journey across its annual highest journey on Sunday, June 20th, marking the longest day of 2021 and the official start of summer for the northern hemisphere. At the June solstice, the sun appears directly overhead at noon when observed from locations on the Tropic of Cancer. Greek astronomer Eratosthenes used this fact and math to calculate the radius of the Earth for the first time 2,200 years ago. He observed that at midsummer, the sun appeared exactly overhead in the Egyptian city of Aswan because its light shone right to the bottom of deep wells. He traveled to Alexandria, a distance of 5,000 stadies away north of Aswan. There, he stuck a stick in the ground and used its shadow to determine the sun was 7 degrees away from the midsummer zenith, implying that a distance of 5,000 stadies around the circumference of the Earth corresponds to a distance of 7 degrees around the Earth's curved surface. Thus, Eratosthenes' experiment provided evidence to the ancient Greeks that the Earth was round, not flat, long before anyone had traveled around it. Many peoples throughout the globe have observed the arrival of the solstice in celebratory ways. Swedish observers collect flowers and herbs such as St. John's wort on the evening of the solstice. The plants are hung in bunches in doorways to wash with the following morning. Doing so aids young lovers in their quest to find a husband or wife. In Portugal, the solstice is celebrated alongside the birthday of St. John the Baptist. Adherents hold street parties with balloons and brightly colored paper decorations, where they also bang each other in the head with rubber hammers for good luck. Still, you could journey to Wiltshire, England to watch the sun flawlessly rise through the rock formation of Stonehenge. Done so perfectly that some scholars believe the structure was built as a kind of stage for the specific event. And of course, here in America, we celebrate summer by letting students take the season off from school. The sun itself will be taking a break this summer and may continue to do so for the next 9 years. Being a living star fueled by hydrogen fusion reactions, the sun is active. Every 11 years or so, the sun's activity increases or decreases as the star's magnetic poles flip. Here on Earth, it'd be like if the North and South Pole swap places every decade. This flipping can result in fluctuations in the sun's magnetic field that can release massive amounts of energy into space in the form of solar flares or CMEs, coronal mass ejections. The sun becoming more active is known as solar maximum, while becoming more dormant is solar minimum. Our current cycle, solar cycle 25, which started in December 2019, observes the sun experiencing solar minimum with an anticipated peak of 115 sunspots to occur in June 2025. If it follows predictions, this cycle will be a particularly weak one, following another weak solar cycle 24. This has led to speculation of a potential grand solar minimum, which last resulted in what's known as the Little Ice Age that lasted from the 13th to 19th centuries. NASA scientists, however, have cautioned that not only is there no indication of such a cooling occurring, but even if it did, today's greenhouse gases far surpass the sun's effects when it comes to changes in the Earth's climate. However, we still know very little about the sun's behavior and its products known as solar weather. To assist in this effort, NASA launched in 2018 the Parker Solar Probe with the specific mission to touch the sun. Parker uses advanced measuring devices like the Fields experiment to accomplish this goal.
Fields is in a special place on the spacecraft. The electronics package is inside the spacecraft where most of the electronics are, but all of our sensors are mounted on the outside of the spacecraft. We have 3 sensors that measure magnetic fields that are mounted on a boom behind the spacecraft in the shadow shield, and then we have 5 sensors that measure plasma voltage. These are electric field sensors. They extend into full sunlight and they get very hot. 2 of the key measurements to understanding coronal heating are the measurement of the magnetic field and the electric field. And together they give us what's called the Poynting flux, which is the energy flux of the corona. And to make those measurements, we have to actually go into that plasma and put sensors in the plasma to measure magnetic fields and electric fields directly, and that's what Fields will do. Solar wind is the escaping atmosphere of the sun. It's the escaping corona of the sun. The corona is heated in a way that we don't understand yet, presumably involving magnetic fields, by energy that comes from below in the photosphere, and it's heated to such a high temperature that it can escape the gravitational potential of the sun and become an escaping wind, a stellar wind, a solar wind. Well, the design of the Fields instrument is a new thing for solar wind physics. It kind of combines 2 previous styles of experimentation. There are 2 ways to measure electric fields in space. One is using a technique that's called a double probe. Then there's another technique which is measuring plasma waves or radio waves. And Fields for the first time brings these 2 techniques together. I think the very first data that we get will be revolutionary. At first blush, it'll just be a bunch of numbers as a function of time. But the science team, will take those numbers and make visualizations in the form of spectrograms, and eventually those data will be related to models, and so we'll be able to compare directly 3D visual models of the coronal magnetic field. These measurements have never been made in the environment close to the sun. We've made measurements similar to this in the Earth's magnetosphere, Earth's ionosphere, but putting a package like this into the solar corona it's just never been done. The closest anyone's ever been to the sun, and based on what we've seen so far from spacecraft not quite as close, it's going to be striking and I think revolutionary.
Fields and the other tools aboard the Parker Solar Probe will help us better understand space weather and its effects here on Earth. Instead of flipping poles, I'm flipping rolls. Now is the part of our discussion where I turn control over to you and your questions and comments as presented in the chat section of this Facebook Live video feed. Of course, at first I see that our friend Craig says that he cannot wait for the next total solar eclipse in our area, which will be in 2024. I too am very excited for that time. Of course, you can anticipate there to be viewing opportunities here at the Danville Science Center, as we did for the last total solar eclipse, the grand solar eclipse that happened just a few years ago, and of course can be seen throughout the entire United States. I think that is what Craig is referring to in 2024. The next one that can be seen, of course, across the entire country. It's pretty awesome. And sometimes people ask, well, the sun's big, the moon's relatively small, Earth's big. How can we block one out with the other when they're different sizes? It also has to do with that distance. If you've ever held your thumb up at night and you were able to block out the moon, that doesn't mean that your thumb is as big as the moon. It just means that the moon is really far away. The Earth, the Sun, and the Moon are pretty far from one another, and that's what allows those sizes to sort of line up. They just happen to be at the right distances that they need to be to make sure that that all lines up perfectly for those amazing events known as eclipses. So, neat stuff. So again, we thank you for all your questions and for joining us here today in the Void. You may have noticed that we've made some changes here in the Void. We are a STEM institution and always trying to improve our experience. Again, if you have questions, feedback, even if you thought about some stuff after we have ended our tour, you can always post those to our Facebook page, and we will attempt to respond to them during next month's Void, which you can join us for in July 2021, the 2020, it's a lot of 20s. Of course, you can join us the second Tuesday of next month, which will be July 13th, when you can join us for another virtual online interstellar discussion presented by Danakid Associates. Until that time, we hope that you stay healthy, stay safe, and of course, stay curious. Goodbye.